There's a paradox at the heart of Europe's changing climate. Scientists say the continent is the fastest warming on Earth, with temperatures rising at more than twice the global average rate. That is no longer a prediction, it's an observable fact. Yet climatologists have long believed that in the long run, Europe could actually cool significantly. In a nutshell, Europe's relatively mild climate depends on a vast system of ocean currents that carry warm water from the south. It's known as the AMOC, the Atlantic Meridional Overturning Circulation. If that system were to collapse, Europe's climate would change dramatically. For decades, scientists saw this as a remote risk, but now new evidence suggests it may be far closer.
A substantial fraction of the models there actually shows that the AMOC is on track to shut down by the end of this century. And the tipping point where this becomes inevitable may even be already in the next few decades.
That's Stefan Rahmstorf. He's a leading climatologist and a professor of the physics of the oceans at the University of Potsdam near Berlin. Research published in the journal Science Advances now predicts that this vital ocean current is significantly more likely to collapse, and the point of no return is closer than we thought.
Basically, we have known that the AMOC has a tipping point since 1961, when a classic study by the famous American oceanographer Henry Stommel was published. And the tipping point means it's a kind of point, if you go beyond that, the AMOC will basically wind down, and that will then cause these major regional climate changes, including cooling in Northwest Europe. And we have long known this, and all the models since the 1960s where they have been tested, they do show this tipping point. The big uncertainty is how far away is this tipping point, and also how fast will the AMOC weaken in response to global warming.
We'll return to the question of timing in a moment, but first, Professor Rahmstorf explains how scientists can make predictions like this and how it relates to a scientific phenomenon technically named the cold blob.
The climate models that we use, they are atmosphere, ocean, sea ice. They have these components included, and they run by the basic equations of physics, thermodynamics, hydrodynamics. And so it has long been predicted by these climate models that we will see a global warming, of course. That was predicted before it was observed, and the climate models have been right about this. And they also included a patch of cooling in the northern Atlantic. That's the only part of the world that is actually being predicted to cool by these climate models, and it is already cooling. This is actually the only part of the world that has cooled. That is the kind of famous cold blob in the northern Atlantic to the west of the British Isles and to the south of Iceland and Greenland. And that is widely regarded as a sign of the AMOC already weakening, because the models predict this cooling there because of less heat being transported by a weakening AMOC into that region.
Professor Rahmstorf has studied the AMOC and its potential collapse for 35 years. Previously, he's put the odds of a full shutdown at around 5%. That's already a pretty alarming percentage for a climate scientist. But now, the predictions are much higher.
Well, there have been stages in the last 5 years which have made this look much more dangerous than I have thought. First of all, a surprising fraction of the standard global warming scenario simulations actually show an AMOC shutdown depending on the emissions. For high emission scenarios, if we continue on the path of high emissions, then even it looks like about 70% of the models lead to an AMOC shutdown. But even for low emissions, it's still 25%. So that really changed my perception that this is like a 5% chance.
So even in the best case scenario, there is a high chance this will happen. You wouldn't get on a plane if there was a 5% chance it would crash, would you? Let alone a 25% chance. Now, there's a lot of science behind this, so let's take a step back and look at how the oceanic conveyor belt works. The AMOC carries warm, salty surface water from the tropics northwards, As it reaches the North Atlantic, that water releases heat into the atmosphere, helping to keep Europe relatively mild. Having cooled and been made even saltier through evaporation, the water becomes dense enough to sink. It then flows back southwards at depth, completing the conveyor belt cycle. But now, global warming is disrupting this process, mainly by making the North Atlantic water fresher and lighter, preventing it from sinking. Now to the tipping point. You might remember the early 2000s Hollywood blockbuster The Day After Tomorrow. If you don't, here's the plot. The glaciers on Greenland melt, flooding the North Atlantic with fresh water and shutting down the conveyor belt, all rooted in real science. Where Hollywood takes creative license is in what happens next. The movie depicts the shutdown as an almost instantaneous event. Within days, the Northern Hemisphere enters a new ice age.
Mr. Vice President, if we don't act now, it's going to be too late.
That isn't how this would unfold in reality, but scientists think we're close to the point where the conveyor belt begins to shut down. Not overnight, but gradually.
We think that this tipping point occurs when the deep mixing in the Northern Atlantic and including the Nordic seas north of Iceland, when that has stopped. And that's the so-called convection, because that means that there is no renewal of the deep water, and this deep water renewal, it's the sinking of water in the high northern latitudes. That is the reason why water is drawn from the south, from the subtropics towards the north, because there in the north it sinks down. Now the problem is that the water that's already down there at depth is heavier than the surface waters now, because the warming of the surface waters makes them less dense, i.e. less heavy. Also dilution with fresh water, that means less salty, also means less heavy. And then this water that is sitting there now doesn't sink so deep and doesn't mix so deep anymore, because it just floats near the surface. And that basically stops that deep water renewal process. And that's the tipping point where then the AMOC winds down over a period of 50 to 100 years.
Okay, so in reality, it will be nothing like a Hollywood movie. It will not take days, but decades. But scientists believe we're already now seeing the effects of the slowdown before we've even reached the tipping point.
Well, there are good arguments, some studies that say we're already noticing these changes because we believe that this cold blob in the Atlantic is due to an AMOC slowing, and the consequences of that cold blob are already influencing our weather. And at the moment, this cold blob kind of stops to the west of Britain. It doesn't actually go over land, but nevertheless, it influences the weather patterns, the pressure patterns. A low pressure system likes to linger over that cold water, as a British study has shown 10 years ago. And if you have a low pressure sitting there and the airflow goes anti-clockwise around the low pressure, that means we get warm air from the southwest, and that makes heat extremes in Europe. So it's a little bit counterintuitive that the cold over the Atlantic actually makes it hotter in Europe, but it is considered one of the reasons why Europe is warming faster than other continents and faster than other regions on similar latitudes.
So what could the weather look like in Europe in 50 to 100 years if this happens?
If the AMOC winds down, there is going to be a balance between increasing warming globally because of increasing greenhouse gases and regionally less heat arriving via the AMOC. And the balance between those two, of course, depends on how much further CO2 we emit and also how quickly the AMOC responds. And so that cannot be predicted with certainty. But the range is between quite a massive cooling affecting especially Britain, Iceland, and Scandinavia in the winter to just reduced warming. So we reduce warming. If we keep emitting a lot of CO2 and we really heat up the world, then even an AMOC slowing can't lead to cooling in Europe. But for more moderate emission scenarios, it can. But the main thing is it also, it's not just the long-term average temperatures that count, of course, but rather what we really feel is the weather. And the weather is probably going to be effective in a massive way because the north then gets relatively cooler, whereas the south of Europe relatively hotter. And that means the temperature difference between the north and the south increases, and that is what drives weather extremes, both in terms of temperature, but also storminess, for example. Another effect is that this AMOC slowing or shutdown makes Europe more dry, but global warming also makes Europe more dry. So in terms of drought risk, these two effects actually don't work against each other, they add up. Another consequence is additional sea level rise by around about 0.5 meter on top of the global sea level rise that is anyway going on. But when you change ocean currents, you also change the regional distribution of sea level.
Is there a way to stop this or to reverse it?
Once we're past the tipping point, there is very likely no way to stop it because self-amplifying feedback takes over and makes it basically unstoppable, self-perpetuating. That is how a tipping point is defined in physics. And the only way to reduce that risk is to reduce our emissions as fast as possible. That means getting out of fossil fuels as fast as we can, making a lot more effort than is happening now, where around the world fossil fuel use is still subsidized massively, for example. That is really crazy.
That's the somber verdict. It's really crazy. But knowing what we know about human behavior and how governments have reacted to the climate crisis in the last decade, does anyone really think we can stop this? I put that to Professor Rahmstorf and got an earnest answer.
I don't make predictions about human behavior. I'm a physicist, so I can only plea and hope that politicians take this seriously and act.
So Europe is both warming faster than anywhere else and potentially cooling long term. But rather than cancelling each other out, this climate paradox would drive our weather to even more extremes. I'm Ole Alsaker in Berlin. Until next time.